Hi students, in this video we are going to discuss another important algorithm, Dijkstras algorithm. It is also called as a single source shortest path routing algorithm. This you will get in data structure subject and design and analysis of algorithms. Not only these two, in computer networks also you will get this algorithm, Dijkstras algorithm, single source shortest path routing algorithm. Okay, so what is this algorithm? This algorithm was designed by the scientist Dijkstras, that's why the name Dijkstras. So, single source, that means we have to start from one point, shortest path routing. We will start from one point and suppose these are some other points. Now we have to calculate the shortest distance from this source vertex. From source vertex to this vertex, what is the shortest distance? From source vertex to this vertex, what is the shortest distance? From this vertex to this vertex, what is the shortest distance? From this to this, what is the shortest distance? From this to this, what is the shortest? From this to this, what is the shortest distance? So, from source vertex, we are calculating the shortest path. And why it is called as routing? See, from this source vertex, you can reach to this vertex by using these vertices, or maybe by using these vertices from you can reach here. Okay, so that route also we are finding. That's why this is called single source shortest path routing algorithm. That means, for example, another example you can consider. For example, you have several cities. So this is one city, this is one city, this is one city. Or you can take like this, some cities here. I am taking some C1, C2, C3, and this is S, C4, C5, C6. Okay. So now from this is called as a source. Source here it is nothing but starting vertex. Source is nothing but a starting vertex. Okay. Start from this vertex. You have to visit all the cities. This is the source city. That means I am in my current location. That is the source. From this location, you want to travel to this city 1. Then what is the shortest distance? Okay. Now, from this to this, what is the shortest distance? By using which path? By using which path you can travel to city 2 in a shortest distance. In a shortest distance. Similarly, suppose from this to this city, what is the shortest distance? That means cost. How much time it will take, or what is the shortest distance? By using which path? By using which path you can reach to city 3 with lowest cost. With lowest cost. Similarly, source this 2, I want to travel to city 4. What is the shortest distance and what is the path? Distance and also path we have to find out. Similarly, this is source to city 5. Again from source to city 6. What is the shortest distance? And what is the path we have to choose? Okay. So, this you can know by using one algorithm. That algorithm is shortest path routing algorithm. Only one source is there. That's why shortest path, single source shortest path routing algorithm. Now, let us take an example. For example, some A, B, C, D, E. Suppose consider a directed graph and also weights. Suppose 3. I will write the costs later. example, I will write the cos 2, some 3, here it is 4, some here it is 5, and the source vertex is this one. This is the source vertex. So if you have seen my video Prince algorithm, we represented some distance table. In the same manner, here also we will represent the distance table. How can we represent and how can we calculate? Totally how many vertices are there? Totally 5 vertices are there. So here I am representing vertex, and then whether that vertex is visited or not, and what is the distance, and from which vertex, that is the distance. So A, B, C, D, E. Okay. So initially all vertices are not visited now. We will make that visited value 0, and we don't know the distances. That's why we will make it as infinity. Okay. And from the vertex, this is a starting vertex. So A vertex to A vertex. So here we will not write. From which vertex, that we don't know. So that's why we are not writing that. So next, vertex visited or not, distance from the vertex. Now write as it is vertices A, B, C, D, E, and A is the starting vertex now. So make that vertex as visited. Make that vertex as visited. And A vertex to A vertex, distance is 0. From the same vertex, it is nothing. From the same vertex. Now, find out adjacent vertices for A vertex. Adjacent vertices for A vertex are B and D. A to B, the distance is 2. See? And remaining are unvisited now. A to B, the distance is 2 units from the vertex A. A to D, the distance is 4 units from the vertex A. So, these are only the 2 adjacent vertices. So, for A vertex, remaining or infinity, we will not write anything. Okay, next. Four columns. V, visited or not, distance from the vertex. Okay. Now A, B, C, D, E. So now this A vertex is visited. So now from the visited vertices. So now next, which vertex you have to visit? Next, which vertex we have to visit? From the remaining unvisited vertices. From the remaining unvisited vertices. From the remaining unvisited vertices, we have to visit vertex B. So make that vertex as visited. So now remaining all are unvisited. This is already visited, write down this as it is. This is already visited, write down as it is. Now we have visited vertex B. B vertex adjacent vertices. B vertex adjacent vertices are C and E. C, what is the distance? B to C, 3. But we have to calculate the shortest distance from A. So up to B, what is the distance? Here it is 2. Already 2. B vertex already distance is 2. From B to C, the distance is 3. Totally 2 plus 3. 5 is the total distance to C vertex from the vertex A. So What is the old distance? Old distance is infinity. So now the new distance is 5. So 5 from which vertex? From the vertex B. From the vertex here it is B. Next, B vertex adjacent vertex is E. E. So D is as it is. D is as it is for A. E. E adjacent vertex. Okay. So A to B, already the distance is 2 units. Now the distance we have to calculate from source vertex A. That's why 2 plus 3, 5 units. Old distance is infinity. New distance is 5 units. So new distance is less than old distance. That's why we will update. So here it is 5. From which vertex it is? From the vertex B. So now these are the distances. So now next, from the unvisited vertices, which vertex we will visit? Whatever the shortest distance we will visit that vertex. So now we will visit vertex D. Vertex V. Vertex V visited VI. So VI, the distance DI, and from which vertex it is. So now, remember, so first we will write the vertices which are already visited. So A and B are already visited, write down those rows as it is. So now A, B, C, D, E. Okay, so 1, 0, 1, 2, A. Now which vertex we are visiting? D vertex. Visited 1. This is 4 from A. Now D vertex. So D vertex adjacent vertices. So there are no adjacent vertices for D vertex. So in this table there is no updation. So write down as it is 0, 5, B. Next here 0, again 5, B. Like that you have to repeat the process until all the vertices are visited. Now see, these two are unvisited vertices. Now in between these two, which vertex we have to visit first? So what is the minimum cost? Which vertex is having minimum cost? Both are having 5 units. Then what shall we do? Whatever the for Q data structure we will use. Whatever the first vertex, we will visit that vertex. So in the next step, vertex visited or not, distance from the vertex A, B, C, D, E. 1, write down the rows which are having visited value 1. So D, 1, 4, A. Now which vertex we are visiting? C vertex. So 1, 5, B. Now we visited C. Find adjacent vertices for C. C adjacent vertex only E. Okay. So now E already having distance 5 units. To C vertex already the distance is 5 units. Okay. So now if we add 5 plus 2, the distance is 7 units. 5 and 7, which one is small? 5 is small. So there is no updation. What does it mean here? Which means A to B, B to C, and then C to E, the distance is 2 from source vertex. 2 plus 3 plus 2, 7 units. Okay. Next, from A to B, directly B to E, you can go, which is 5 units. Which one we will prefer? Which is the shortest distance only. That's why here we will not update 5B, we will write as it is. Okay, next. Now which one is unvisited? E only. In the next step, just visit vertex V only. V, VI, DI from the vertex B. A, B, C, D, E. All are visited now. 5, B, 4, A, 5, B. So this is the shortest path routing algorithm, which is having only one vertex as the source vertex. Single source shortest path routing algorithm. Okay. So what is the meaning of this table? You may get doubt what is the meaning of this table. The meaning of this table is A to A the distance is 0 units. Next A to B. A to B the distance is 2 units. See, A to B the distance is 2 units. A to C the distance is 5 units via vertex B. See, that means A to B, B to C. A to B, B to C, 5 units. Next, A to D, 4 units. A to D, A to D, 4 units. See, direct edge. Okay. Next, A to E, the distance is 5 units by using B. That means A to B, B to E. So, A to B, B to E. The distance is 2 plus 3, 5 units. This is 2 and this is 3. Okay. Like that, you can represent the shortest path, shortest single source, shortest path routing algorithm. Without representing this distance table also, you can do like this. Suppose A, B, another example, single source shortest path routing, D, E, F. For example, if this is the graph. Suppose this is the graph. Okay. So now I am writing the edges 2, 3, 4, 5, 3, 2, 4. Source vertex is A. Source vertex is A. Okay. Initially, see, we don't know from which vertex and we don't know the distance. So like this you can write. So we will write some ordered pair like this is the vertex and this is the distance. Okay. From here you can represent like this. A, B, C, D, E, F. Now A to B. Just I am writing as it is graph. Without representing the table, in the graph itself you can mention the distances. So 2, 3, 4, 5, 3, 4. This is the starting vertex. Now update these distances. Now I am updating. So now this is the starting vertex. Okay. Now here A comma, previously it is dash and infinity. Now here A comma distance is 2 units and here it is 4 comma A, or you can write from the vertex A the distance is 4 units. Remaining all are infinity. You can write those. See here infinity. We don't know the distances, like represent infinity. Okay. Now see the distances. Here it is 2 units. Here it is 4 units. Which one is the shortest distance? 2 units. That's why we will visit this B vertex. First we have visited A. Next we will visit B. Okay. So we are visiting B. B vertex adjacent vertices are. B vertex adjacent vertices are C and F. C, the distance is infinity here. Now the distance is already to B 2 units and here it is 3. So The distance is 5 from the vertex B. So this will be updated. Why? Because infinity is greater than this 5. Next, B adjacent vertices are C is visited now. That means C distance is updated. Now find out F distance. So now here distance is infinity. So we will update. Like B vertex, already here it is 2 units and this is 2 units. So 4 units. Now next, which vertex we will visit? So this is a next distance diagram. Now see, this is already visited. Now this is already visited. Now from the remaining unvisited vertices, which one we will visit? Here the distance is 5 units, here the distance is 4 units, here the distance is 4 units. Which one we will visit? First, which one we will get? Minimum distance is 4 units. So E and F both are having 4 units. So which vertex we will visit? Vertex E we will visit. So visit vertex E now. Now represent that A, B, C, D, E, F. Okay. So now write down the graph just as it is. This is the starting vertex. Here it is 2, 2, 3, 4, 5, 3, 4. Okay. So now which vertex we are visiting? 4 units distance, which is short, and this is the first vertex. Now we are visiting E vertex. So that means A visited already, B visited already. So here the distance is A comma 2 and here the distance is A comma 4. This vertex is visited. Okay. So now find adjacent vertices for E vertex. E vertex adjacent vertices, only one vertex, which is F. Okay, so to F vertex, what is the distance of 4 plus 3, 7 units. Already what is the distance here? 7 units by using B. So 7 and old distance is 4. So what happened here? New distance is greater than old distance. So we will not update. So we will take this as B comma 4 only. We won't update. Remaining are as it is. B comma 5 and this we don't. Okay. Now in the next step, which one we will visit now? So now in the next step, now I am representing here A, B. Write the as it is. Instead of representing the tables, we are writing in the graphs only. Okay. F, E, four, 2, 3, 4, 5, 3, 2. Okay. Now these are already visited. You write down as it is. Visited vertices. This is from A vertex, the distance is 2 units, already visited. From A vertex, the distance is 4 units, already visited. Now which vertex we will visit? Here it is 5, here it is 4, here it is infinity. Which one we will visit? This F vertex we will visit. So B comma 4. Now find B vertex adjacent vertices. F vertex adjacent vertices. There are no F vertex adjacent vertices. Simple. So next, which vertex we have to visit? 5, infinity. Which vertex we will visit now? C vertex we will visit. So this is also visited. B comma 5. Now what are adjacent vertices for C? D vertex. So D vertex, what is the distance here? Already to C 5 units. 5 plus 4, 9 units. 9 units. So from which vertex here it is? From the vertex C. C comma 9. Now this is also visited. So now see the distances. So from A vertex the distance is 2 units. From A vertex the distance is 5 units by vertex B. A to E directed C. So A to F via B. Via this one 7 units. Like this it is 4 units. So we will consider this one only. Okay, so here also 2 plus 3 plus 4, 7 units, 9 units. So like this also you can represent. So this is another way of solving this Dijkstras algorithm, single source shortest path routing algorithm. So hope you understand, students. If you like the video, please share with your friends and subscribe the channel. Thank you, students. Have a great day. Bye.